Welcome to this lesson on the properties of ionic compounds. Ionic compounds are substances formed through chemical bonding between metals and nonmetals, and they exhibit several unique characteristics that make them distinct from other types of compounds. In this video, we'll explore their most important properties, including their high melting points, electrical conductivity, and other key features that arise from their unique structure. Ionic compounds are chemical substances formed by the electrostatic attraction between oppositely charged ions. These ions form when atoms transfer electrons during chemical reactions. Metal atoms lose electrons to become positively charged cations, while nonmetal atoms gain electrons to become negatively charged anions. A common example is sodium chloride, or table salt. Sodium, which is represented as Na+, combines with chloride, represented as Cl-, to form sodium chloride. And a Cl, this electrostatic force holding the ions together, is called an ionic bond. One of the most characteristic properties of ionic compounds is their exceptionally high melting and boiling points. This occurs because ionic compounds are held together by strong electrostatic forces between positive and negative ions. These ions are arranged in a three-dimensional crystal lattice structure, where each ion is surrounded by ions of opposite charge. Breaking this structure requires a tremendous amount of energy, which is why ionic compounds typically need temperatures exceeding 800 degrees Celsius to melt. The stronger the ionic bonds, the higher the melting point will be. Let's look at some real-world examples of ionic compounds and their melting points. Sodium chloride, or common table salt with the formula NaCl, melts at 801 degrees Celsius. Magnesium oxide, MgO, has an even higher melting point of 2,852 degrees Celsius due to the stronger attraction between doubly charged ions. Calcium chloride, CaCl2, melts at 772 degrees Celsius, while potassium bromide, KBr, has a melting point of 734 degrees Celsius. These high values demonstrate the incredible strength of ionic bonds. Ionic compounds have an interesting property when it comes to electrical conductivity. In their solid state, ionic compounds do not conduct electricity. This is because the ions are fixed in their lattice positions and cannot move freely to carry an electric charge. However, when ionic compounds are melted or dissolved in water to form an aqueous solution, they become excellent conductors of electricity. This happens because the ions are now free to move throughout the liquid. These mobile charged particles can carry electrical current from one point to another, making molten or dissolved ionic compounds effective conductors. Let's understand the process of electrical conduction in molten ionic compounds through three key steps. First, when heat is applied to an ionic compound, the thermal energy provides enough force to break down the rigid crystal lattice structure. Second, once the lattice breaks apart, the ions that were previously locked in fixed positions become mobile and can move freely throughout the liquid. Third, when an electric potential is applied, these mobile ions migrate toward oppositely charged electrodes, carrying electric charge through the substance. This movement of charged particles constitutes an electric current, which is why molten ionic compounds are used in various industrial processes. Beyond high melting points and conductivity, ionic compounds possess several other important properties. They are hard and brittle. The strong ionic bonds make them resistant to deformation, but when force is applied, layers of ions can shift, causing like charges to repel and the crystal to shatter. Most ionic compounds are soluble in water because polar water molecules can separate and surround individual ions in a process called hydration. Ionic compounds form crystals with regular geometric patterns that reflect their repeating three-dimensional lattice structure. Finally, they are non-volatile, meaning they do not easily evaporate at room temperature because the strong ionic bonds prevent ions from escaping into the gas phase. Let's summarize the essential properties of ionic compounds. First, they have high melting and boiling points due to the strong electrostatic forces holding ions together in the crystal lattice. Second, they conduct electricity when molten or dissolved in water, but not in solid state, because ions must be mobile to carry charge. Third, they are hard and brittle with a crystalline structure that can shatter when stressed. Fourth, they are generally soluble in polar solvents like water. All these properties arise from the fundamental nature of ionic bonding and the electrostatic forces within the crystal lattice. Understanding these properties helps us predict how ionic compounds will behave in different conditions and explains their many practical applications in chemistry and industry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.